Now this function is asking us to compute those 1, 2, 3, 4, 5, 6 limits, and it's a piecewise defined function, meaning it has, in this case, 3 different definitions depending on the x value. So how are we going to solve this problem based on these facts that I just mentioned? So the first question is the limit when x approaches 4, negative 4 from the left of g of x. So negative 4 from the left, it means we're less than negative 4. So the function value is 0. X approaches negative 4 from the left. 0 is a constant, so the answer for this is 0. On B, the limit when x approaches negative 4 from the right of g of x, so we're immediately to the right of negative 4. So this is also to the right of negative 4, right? So it's all the way at 4, but it's too far to the right. This is immediately to the right of negative 4 because we're close to negative 4. So the function value we're using is the middle one. Now we are allowed to plug in negative 4, which is the limit. X goes to negative 4. Well, once I plug in, I no longer write the limit, so that's 16 minus 4 squared. The fact that x is bigger than negative 4, right? This is something that I have to check before I plug things in. X is bigger than negative 4 because we're to the right of it. Makes it so that x squared is less than 16. Think about it graphically. If this is negative 4, then bigger than negative 4 means it's like minus 3.9 or something. So x squared is less than 16. We're bigger than negative 4, but very close to negative 4. Right? So this is well defined. So it's always something you need to check when you're plugging things in for your limit. And now that we have checked this, right? This is less than 16. So this is 16 minus something less than 16. This is positive. I'm able to take the square root of a positive number. And the answer for this is 16 minus 16, which is also 0. Now on C, the limit when x approaches negative 4 of g of x is also 0 because both one-sided limits exist and are equal to 0. That's the answers from A and B. Now on D, we're asking the limit when x approaches 4 from the left. So we're immediately to the left of 4. Same thing happened. So we're using the same definition, and it's the same check we need to make. X is less than 4, so x squared is less than 16. You can think about it graphically again. You know, on the line, if this is 4 and x is less than 4, this is like a positive 3.9. So if I make it a little bit bigger, it's 4. This is a positive 3.9. If you square that, then this is still less than 16. So this is well defined. And we then also get the 0. Right? We also get the square root of 16 minus 4 squared, which is 0. Now, E is the limit of g of x. X goes to 4 from the right. X is bigger than 4 now, so we're using this formula. So we're saying that this is the limit when x approaches 4 from the right, and that equals to 2 times x, right? G of x is 2 times x, so that's 2 times 4 rather. I'd write in the correct order, and that will be an 8. So then the answer for F is that the limit does not exist, because now we're using the two-sided limit. the one-sided limits are different. So that's how you solve this type of one-sided limit question.